Good morning, class. We are going to over the last chapter of our syllabus of SEMED PC3 is analgesic. In this analgesic, there are two parts. One is the opoid analgesic, and second part that is the non-steroidal anti-inflammatory drugs. Okay, so we will start with the first part that is narcotic analgesic. It is also called as opoid analgesic. Okay, so what do you mean by analgesic? So the drugs which are useful for the relieving the pain, they are called as analgesic. They are also called as antineuroreceptives. For examples, non-steroidal anti-inflammatory agents, they are also useful for the relief from moderate pain. Some local anesthetics are there. Okay. So morphine and its derivative, they having the unique role among all other analgesic in reducing the pain. Okay. So morphine is the example of opioid analgesic drug. It is also called as the narcotic analgesic. It is often from a plant, okay, papaya, and is main chemical which is the psychoactive, that chemical is called as opium. So morphine is regarded as gold standard analgesic. It is used to relieve intense pain. Generally the non-steroidal anti-inflammatory drugs, they are also useful for the relieving the pain, but they are useful for the relieving the moderate pain. But this morphine, that is the non opioid analgesic, they are useful for the relieving the intensive pain or the intense pain. They directly act on central nervous system to relieve the pain. So these are some examples of opioid analgesics, that is the morphine, hydrocodone, oxycodone. So these are some examples which are related with the opioid analgesic. Hmm. So generally the juice or the latex which are obtained from a seeds of papaya is the useful for the treatment of a analgesic. So during the history you find out that Theophrastus, it describes its uses of opium in 200 BC. Generally, it was used as a tonic. In 1802, it is obtained an alkaloid succinate from the opium, and his name succinate is named as the morphine, after the Morpheus, the Greek god of dreams. So, morphine among the first drug undergoes structure modification, that is the ethyl morphine, and it was introduced in 1898. That is the drug diacetyl morphine. So the next part, that is the mode of action of opioid analgesics. Okay, so opioids are generally known as agonists of endogenous substances, and these substances they are known as endorphin. Okay, so it is the group of structures which look like the morphine. So they are the endogenous, so they are already present in our body. They perform this function. So morphine, they are we are giving as a drug. Okay, they are not morphine, are not synthesized in our body. For the endorphin, second one dynorphin and enkephalin, which represents the similar members of endorphin. They are generally present in our body in the central nervous system, which are responsible for the binding to the receptor, and they are responsible for relieving the pain. Okay, so these are the endogenous peptides or the endogenous material which are present in our body. So morphine is the external part. So it is a agonist which is given for the endorphin. So generally opioids, their activity is found or their effect located in the central nervous system. So specific receptors they are present in the brain. They shows the different narcotic activity lead to the different side effects. So this endorphin, it binds to the mu receptor and it function as the analgesic. The endorphin binds to the kappa receptor It produces analgesic as well as the sedation, and this enkephalin is binds to the delta receptor. It produces analgesia along with the dysphoria. Okay, so these are the various actions of the different endogenous material which is present, which shows the narcotic analgesic activity. Generally, these opioids they have shown to inhibit either basal or neurotransmitter stimulated increased level of adenyl cyclase activity. Adenyl cyclase. So this is inhibited by the opioid analgesic. Okay. So this is found, or this activity of inhibition of adenyl cyclase, it is found in various areas which are present in the mammalian or the human central nervous system. Due to the inhibition of adenyl cyclase, it involves the stimulation of high affinity membrane associated with GI paths. GI paths. Okay. So hence there is a stimulation of the GI phase. It activates the guanine nucleotide regulatory binding protein, that is the G protein, and thus under the influence of peptide, that is the enkephalin, it fails to release the neurotransmitter in synaptic cleft, and pain impulses it is not received by the postsynaptic neurons. So opioid mediated fall in cyclic MP levels, it releases or it is responsible for the analgesic activity. Okay, so that is the mechanism or mode of action of the opioid analgesic. So the opioid analgesic, what it does, it inhibits the adenyl cyclase. So this adenyl cyclase is responsible to stimulate GI paths, and due to the activation of this or stimulation of GI paths, the activation of guanine nucleotide regulatory binding proteins G takes place. And when such cases takes place, it is difficult to release the neurotransmitter into the synaptic cleft, which is responsible for the transfer of pain impulses, and hence pain impulses is not received by the postsynaptic neuron. So that is the mechanism of action of opioid analgesic. Okay. Okay. So these are the presynaptic nerve. These are the terminals. Here generally opioid receptor is present. At this part there is a opioid receptor is present. Okay. So this is the postsynaptic neuron. Okay. So this is presynaptic. This is the postsynaptic neuron. Okay, so this is presynaptic neuron, this is postsynaptic neuron, this is the opioid receptor, and this is, suppose this part is the encephalinergic neurons, which is responsible to secrete the enkephalin, which is the opioid. So this encephalinergic receptor, it releases the enkephalin, that is the opioid. This opioid binds to this opioid receptor, and when the opioid receptor is binded with the enkephalin, then it blocks the release of neurotransmitter from these to the postsynaptic neuron. So no role of enkephalin in pain impulse perception. This perception does not take place due to the binding of opioids to these receptors. So in this way, the pain impulses they are not received, so it does not feel, or the person or patient it will not feel the pain. Next part, that is the opioid receptor. So as we have told, there are three opioid receptors are there. One is the mu receptor, second is the kappa receptor, third one is the delta receptor. So these are the three receptors which are responsible for the inhibition of voltage gated calcium channel as well as the opening of potassium channel, which results into hyperpolarization. So we know that the impulse are transferred when there is a depolarization is present. If there is a hyperpolarization or polarization state is there, the impulses are not transferred from one cell to the another cell. Hence, these opioid, what they do, they binds to this receptor, one of these receptor, it is the mu, kappa or delta receptor. They are responsible for the inhibition of calcium channel and opening of potassium channel. So due to that, potassium goes outside. So outside positive charge increases, inside negative charge increases. So hyperpolarization state is formed, and this hyperpolarization results into the resting state, that is the no transfer of nerve impulses from one cell to the another cell. So in this way, the binding of morphine to the receptor takes place. So the opiates, it suppress the curve center, which is also located in the brain in the medulla. So it also shows the curve suppressor. Okay. So the major medical action of morphine is the same as in the analgesic. So morphine exerts the narcotic action by the analgesic, drowsiness, change in mood, as well as the mental clouding. So in this way, the binding of the morphine to the receptor takes place. So the anionic side is also there, flat area for aromatic ring and cavity for the ring. So these are the part of the receptor. This is the structure. So in this way, the morphine binds to the receptor and it will show the narcotic activity. Okay, so these are some morphine derivatives. So morphine is there, codeine, heroin, morphine, and hydromorphone, hydrocodone, oxycodone, liverfol. So these are some examples which comes under the narcotic analgesic or opioid analgesic, which are the morphine derivatives. So when allyl or cyclopropyl methyl group is attached to the nitrogen, so here nitrogen is present. So this nitrogen, if naloxone, naltrexone, norepinephrine, if you observe the structure of these three, these are the antagonist or the morphine. So when they comes to antagonist, so if you see the structure of morphine, there is on nitrogen, there is CH3 is present. But if this CH3 is replaced by allyl group, so here you can see allyl group, cyclopropyl methylene group, here cyclopropyl and methylene group, or allyl group in case of norepinephrine. So such examples are, or the such modifications, if they are present in the morphine derivatives, so such drugs, it becomes antagonist instead of undergoing the agonist activity. So this is the structure of morphine. Just go through it. So morphine and its structure. So the morphine is a pentacyclic structure. Okay, so this is A, B, C, D, and this is E. So there are pentameric structure is present. So it consists of 5 cycles. So it is called as the pentacyclic structure, in which A ring is present. Okay, so this A ring is benzene ring. Then B and C, if you observe, there is absence of double bond. Okay, in C there is a single double bond is present. In B there is a single double bond is present. So such ring is unsaturated cyclohexene ring. So B and C are the unsaturated cyclohexane ring. Then this D ring, you can observe, it is the piperidine. D ring, you can observe that this D ring is the tetrahydrofuran, and this A ring is the piperidine ring. So piperidine ring is E, and this tetrahydrofuran ring is D ring. So ring A, B, and C, they are the phenanthrene ring system, or they are called as the phenanthrene ring. So A ring is the completely saturated, unsaturated, that is the benzene ring is present. B and C are the half saturated or unsaturated is present. Okay, then two hydroxy groups are present. Okay, one has the C3 phenol, another one has the C6 phenol. So C3 phenol is in the one plane, C6 phenol it is shown by the dotted line, so it is the out of plane. Then there is ether linkage is present. You can observe there is ether linkage is present between C4 and C5. Then unsaturation between C7 and C8 takes place. The basic 3 amino function is present at the 17 position. So this is some important factors regarding the morphine. In morphine, there are 5 chiral centers are present. First one, C5. Okay, so this is the chiral center. You can observe one, two, three, and fourth one is hydrogen. So it is attached with the 4 different groups. So it is chiral center. And similarly, C6, then C9, then C13, and this is C14. So these are the 5 chiral centers which are present in the structure of morphine. The next part is structural modification and the structure activity relationship of morphine. Okay, so this is the structure of morphine. Okay, so this part is generally R. Okay, R is OH or the phenolic OH, that means it becomes the morphine. If this R is methyl group, that is the OCH3 is present, it becomes codeine. O oxygen as it is and CH3. If it is OC2H5, it becomes ethyl morphine. And if that is the acetyl group, R acid is equal to acetyl, it becomes the 3-acetyl morphine. So by methylating this morphine of phenolic OH, the analgesic activity drops by 0.1% as compared to the morphine. So free phenolic group is crucial and it is important for the analgesic activity. Similarly, at the sixth position, there is OH group is present. So if it is methyl, it becomes heterocodeine. If it is ethyl, it becomes 6-ethyl morphine. If it is acetyl group, it becomes 6-acetyl morphine. So it having 5 times more activity as compared to the morphine. This ethyl having greater activity as compared to the morphine. 6-acetyl it having 4 times greater activity as compared to the morphine. So all the groups are same. Here R dash. If R dash is H means hydroxy group and this is also the hydroxy group, then it will increases or having the similar kind of activity. So these substitutions it can be gives the increased activity or it gives the similar kind of activity. So it shows that the complete loss of alkyl group does not decrease the analgesic activity. In fact, it will increases the activity. So if both the groups they are converted into acetyl form, that is the hydroxy group which is present at the third position and hydroxy which is group which is present at the sixth position, if these both the groups if they are converted into the acetyl group, then it becomes diacetyl morphine. This structure is called as dimorphine. It is also called as the heroine. So heroine has 2 polar groups which are marked with the acetyl group. So to conclude, 6-hydroxy group is not necessary for the analgesic activity. So this is about some summary part of the structure activity relationship. So removal of hydroxy group at the third position, it will decreases the activity. If this ether linkage is removed, it will increases the activity. This hydroxy group, it undergo oxidation, reduction, or coupled with the 7 or 8 double bond, it will be produced. It will increases the activity. This nitrogen, if it is converted into CH2 CH2 phenyl group, it will increases the activity. But if it is converted into the allyl group, it produces the antagonist activity. As well as at this 14 position, if hydroxy group is introduced, it will increases the activity. And this double bond, if it is removed, it will reduction of this double bond takes place. It will increases the activity. In morphine, as we know that there are five chiral centers are present. That is 5, 6, 9, 13, and 14. So these are the five carbons which are having the four different groups. So they are asymmetric center on the chiral center. So at the 5 position, they have configuration that is R. Okay, so 5R, 6S, 9R, 13S, and 14R. So 5R, 6S, 9R, 13S, and 14R. These are the absolute configuration of the morphine. Okay, so this morphine, so during the derivatives of morphine, as we have mentioned, there are two hydroxy groups are present, it gives the morphine. But if R, one of the R is replaced with the CH3, it leads to the, or this R, if it is CH3, it leads to the formation of codeine. If CH5, it formation of ethyl morphine. And acetyl group present on this as well as this part, it becomes the heroin. So this codeine is 1/10 analgesic as compared to the morphine. So morphine is more analgesic as compared to the codeine. So hydroxy group is necessary to show the analgesic activity. So a free phenolic hydroxy group having the greater potency. Then the drug heroin is more potent despite having the weaker opioid receptor binding affinity. So it having the acetyl group, so it is difficult for heroin to undergo the metabolism. So when it undergo metabolism, it forms an active drug. So heroin is a more lipophilic as compared to the morphine, and when it enters into the body, it immediately converted into the active metabolite, that is the 6-acetyl morphine and morphine. So in case of heroin, there are two acetyl groups are present. So hydrolysis takes place, and when hydrolysis takes place, first this third position acetyl group, it is converted into hydroxy group. So it is 6-acetyl morphine, and then remaining this it undergo again hydroxy. It is the hydrolysis takes place, so two hydroxy groups, so it forms the morphine, which is the active metabolites of the heroin. Okay, so these are some examples of other morphine derivatives: hydromorphone, hydrocodone, oxycodone, as well as the phone, methyl hydromorphone. So these are some other examples of the morphine derivatives. So this sixth position, if it undergo methylation, this sixth position, if it undergo methylation, oxidation, it is removed, it is replaced with other groups in order to get more potent. So the potency will increase, but along with the potency, the toxicity of the drug is also increases. So examples are the codeine, heroin, chloromorphine. So they're having the more potency, but along with that, there may be chances to increase the toxicity. Then at 8th position, so C7 and C8. Okay, so there is a double bond is present. If it undergo hydrogenation, that is the double bond is removed, then it forms the drug that is the dihydrocodone and dihydromorphine, which are more potent. Okay, as well as at the 8th position. So here there is a double bond, so it can be reduced. Then it will increases the potency. Or if the halogen derivatives or a halogen group is attached at the 8th position, it will increases the potency. Then the 14th position, if at the 14th position, that is this position. So if at a 14th position, if hydroxy group is attached, it becomes more potent compound. If the bridging between C6 and C14 takes place through ethylene, it is called as ethorphine. So at that time, it becomes more potent than morphine in the main. So these are some important parameters regarding which the increase in the potency of drug takes place in some modification will be done. Next part during the SIR is that these are the impact benzene ring. It is required for the analgesic activity. At third position, hydroxy group is present. It will require for the activity. Then, if any substitution will be done, then it will maybe chances of decreasing the activity. Then here the tertiary nitrogen is present. Okay, so when R is methyl, okay, like this group, methyl group or hexyl chain, it results into the opoid ergony. So as we discuss, if it is converted into the allyl group, the phenyl ethyl group or cycloalkyl methyl group, it will convert it into the antagonist agent. For example, we have seen nolorphine, naloxone, naltrexone. So these are the antagonists which having the allyl group attached to the this position. Then next part regarding the SAR, they found that the cyclic ring is not necessary to show the activity. So there some modifications can be done in the ring, or ring can be reduced to the single or double member ring so that it will show in the activity. So during that in 1930, their introduction of drug that is the meperidine takes place. So this meperidine having the antispasmodic as well as the sedative activity, as it also shows the anticholinergic activity. Okay. Further study indicate that meperidine having the only 10 to 12% of morphine activity. So morphine, as it is a cyclic structure, it shows the better activity. But meperidine also show the better good activity as an analgesic. But along with that, it having the anticholinergic effect. So it will more showing the antispasmodic as the sedative properties. So it having only the 10 to 12% of activity as compared to the morphine. Okay. So regarding the SAR of meperidine, which is having only 10 to 12% activity of the morphine. So if we replace these four phenyl ring with any hydrogen alkyl group or heterocyclic group, it will decreases the activity. So phenyl group is necessary for the activity. Then the N substitution analogs has been prepared, which will show the more activity. For example, allylaride. So it can found that it is the N substituted analogs. When N substituted analog has been done, it will show the better and potent activity. Then replacement of carboethoxyl group by acyloxy group results in better analgesic activity. So it is COOC2H5. So instead of that, if we convert it into OCO C2H5, that is the acyloxy group. So instead of COCTH5, we can convert it into COCTH5. It will result into the better analgesic activity. Then at N methyl group, if we replace with the ara alkyl group, it will increase the analgesic activity. The series of compounds were prepared using the piperidine to the 7-member ring azepine. So piperidine is converted, it is 6 members, so it is converted into 7-member azepine ring, which also shows the better activity. So here we observe that piperidine derivatives, you can observe here, here, as well as the here. So all these groups, the phenyl ring is attached to the piperidine ring with the without carbon, or it directly attaches to the phenyl ring. But if through any atom like nitrogen, if it is attached, then it will result into the drug that is the fentanyl. It will use the series of the drug that is the fentanyl, where the phenyl ring and the acyl group, they are separated with the help of a nitrogen. So in that fentanyl ring, alphentynyl, so fentanyl, so these are the examples which are next analog. So morphine, from morphine, uh, we have the 5-member ring. From morphine we converted into 2-member ring, that is the meperidine. In meperidine, the phenyl ring is directly attached to the piperidine ring. Then next series comes, that is the fentanyl series, in which nitrogen is present, which is attachment of the phenyl ring to the piperidine ring takes place. Okay, so in that there is a drugs called as fentanyl is the example, then sulfentanyl, alphenanyl, these are the examples which comes under this group. And now the next series comes, that is the methadone series. So further simplification of this morphine nucleus by opening the nitrogen ring resulted into the methadone series. So methadone itself having the analgesic activity as well as it having the spasmolytic activity. Then this methadone series, we observe that this methadone series in which the nitrogen ring is open. So this is the nitrogen ring is open. So this is the structure of drug that is the methadone. Okay, so this is the structure. Here benzene ring is present, benzene ring, here COCH5, then CH2, CH, then one CH attached to the CH3, other attached to the nitrogen, and this nitrogen having two methyl groups. So this is the methadone series. Okay, so this methadone series is the next series to the drug that is called as the fentanyl. So this way the development as well as the SAR of the morphine takes place.